Hello everyone. In this presentation, we are going to understand about definition and basic types of data structure. Myself, Dr.A. Victoria Anand Mary, Assistant Professor, PG and Research Department of Computer Science, St.Joseph College of Arts and Science Autonomous, Cuddalore. Let's start with the very basic definition of a data structures. A data structure is the way of organizing data in a better way so that we may retrieve it faster whenever we are in need of. The data items can be of any type. They can be of integer, float, character, string, etc. Now let's see the classification of data structure. There are two major types of data structures, that is primitive data structure and non-primitive data structure. Primitive is a predefined one and non-primitive is user-defined data structures. The primitive type, as we know that it is a predefined one. It is of an integer type, float, character and pointer type, which is going to have an address of some other variables. And we'll see what is a non-primitive data structure. And the non-primitive data structure is further classified into two types, that is linear and non-linear types. Linear, as the name suggests, we are going to store the data in a sequential pattern, and it will be retrieved in some kind of order. Non-linear type, the data can be of any order. Linear type, we are having array, linked list, stack, queue. In non-linear type, the data structure are graph and trees. These are the topics which we are going to cover in this presentation. Let's start with the primitive data structure. There are basic structures and that is going to operate upon the machine instructions like integer, float, character, strings. In non-primitive data structures, it is more sophisticated data structure and which is been derived from the primitive data structures. And the non-primitive data structure will have a group of homogeneous data types or heterogeneous data types. The homogeneous types can hold data of same type under a common name, whereas in heterogeneous type, it can hold data items of different data types. It will have a combination of various data types together under a common name. The major operations that we are going to perform on the data structures are: we can create a data structure, we can select some of the elements, we can update those elements, we can find some of the elements, or we can search some of the elements that is present in our list. We can arrange those elements, that is sorting. We can merge some of the nodes, and we can delete the data which we don't need in future. The first data type that we saw in a linear structure was an array. Now we'll see what is an array in detail. Here the array is declared where int is a data type and ARR is a array name. This is a user defined name and the array size is 10. That is the maximum values that we can store in an array is 10. And the index of an array will start with 0. That is from 0 to till 9 we can store the values. Each index will have its own elements that we are going to store, and it should be given in a square bracket. This is the basic syntax for declaring an array. We have to give a data type, space, array name, which is a user defined one, and the array size, which will specify the maximum values that we are going to have in an array. This is the simple piece of code which will read the elements that is present in the array and print those elements. For that we are using a for loop. It is a looping structure and it is having 3 parts. First, we'll initialize the variable. I is initialized to 0 and we will check the condition whether this particular I is less than or equal to 9, and it will be incremented each time this particular statement is executed. That is, we are going to print all the values that is present in the array. As we know, in the previous declaration we saw that the array index will start in 0 and it will end at 9. Since array size is 10, all those elements we are going to get from the user. Scanf statement is used for getting the input from the user. The same input we are going to print. That is, for printing those values, we are using a printf statement. Here %d is the format specifier. It will specify the type of value that the array is going to hold. Here %d specify integer value that we are going to get and print. Next we are having a list type. That is, it is other words we can call it as linear linked list, which we are going to store the element in a linked list format. Each value will be stored in a separate node. The place where we are going to store the data can be called as node. Linked list is a data structure which is defined as a collection of data items, and each node in the list contains two fields. One for storing the data and another for storing the address of the next node. Since it is called as linked list, all the lists are linked together. The last node in the link part will be null to represent the end of the list. Here it is been given null, it is null. Next, in the linear list we are having a stack. Stack is also an ordered collection of elements like an array, but it will follow some strategy. That is, as we know, stack is the other name for stack is last in first out. The element that is inserted lastly will be taken out first, and the stack will be having a pointer, that is top pointer, which will represent the top location in a stack. The insertion and deletion will be done only at the top location of the stack. The picture represents the push and pop operation. Insertion of element into the stack is called push operation. When we are going to insert any of the element into the stack, it is called as push, and if you are going to delete the element from the stack, it is called pop. Queue is the other linear data structure which follows the principle of first in first out. That is, the element that is inserted first into the queue will be taken out first or will be processed first, and the new element that we are going to add into the queue will be added at one end called rear end, and the element will be removed from the front end. It is similar to the people standing in a railway reservation, those who want to reserve a ticket. The person who goes first will be processed or will get the ticket first. And now we are going to see a non-linear data structure. That is, the data element will be in a non-linear pattern. Trees and graphs are non-linear data structure. A tree can be defined as a finite set of data items. Here the data items will be placed in a node. We'll be having a countable number of nodes in a tree. Tree is a non-linear type of data structure in which data items are arranged or stored in a sorted sequence. Tree represent a hierarchical relationship between various elements that is present. Each node will be related to another node. This is the diagram representation of a tree. The tree structure is organizes the data into branches and which are related to each other. Here the node A is a root node, followed by B and C, which are children of the root node A, and we can call B and C as a siblings. Likewise, D, E, F, G are siblings. We'll have a hierarchical classification of the nodes that is present in a tree. We can classify the nodes in a hierarchical order in a tree. The other non-linear data structure is graph. It will be similar to a tree, but here in a graph we won't be able to classify the nodes in a hierarchical pattern. We can define a graph as a G of V comma E. It will be given in a capital V and E, where capital V represent the collection of vertices and E represent the collection of edges that is present in a particular graph. And this data structure, as you know, it is made up of a finite number of nodes. The nodes can also be called as vertices, both are same, and the edges that is connecting two nodes. The lines that is connecting the nodes are called as edges. Now we are going to see about the major types of graph. That the first one is undirected graph. We know that edges are the line that is connecting two nodes. In an undirected graph, nodes are connected by the edge and that are all bidirectional. That is, if there is in this diagram, you can see that no direction, no arrow mark is given for traversal. So if nothing is given, we can consider it as a bidirectional traversal. That is, we can move in either directions. Whereas in directed graph, the arrow mark will be given and it represents the direction of traversal. In a undirected graph, nodes are connected by the directed edges. They only go in one direction. We can't have a bidirectional way of traversal. Thank you.